Hello and welcome back to Cogent Technology TV. In our last episode, Michael had some tips on solder dams, so if you haven't seen that, it's worth taking a look. In this episode, we've got a bit of a design tips special. Mike's got 2 tips for you, so let's go over to him and take a look.
Welcome back to my design tips. Today we're going to be running through a number of very small ideas that we'll hopefully find useful. First of all, we're going to start off with going through some PCB design best practice tips. And first of all, we'll be starting with the component land pattern or footprint. In the case of component footprint, we find that we have a lot of issues where designers use the standard package that was defined in your CAD package and hasn't been amended by the customer. We find it's advisable to actually consult the manufacturer's data sheets or the IPC 7351 standard to verify that the dimensions of the copper and resist and any holes are correct for the component to these resources. Examples where this can go very horribly wrong can be if the lands are too large. What we find is we can have solder actually forming what looks like the shape of a joint away from the leg of the component and not actually attaching itself to the component, and therefore giving us false AOI passes. Other problems can be if the land patterns are too small. This gives us then a joint where we either can't see the visible solder at all, or in the worst case a dry joint which isn't actually sufficient to solder the component termination to the PCB. Okay, the next guidelines to consider then in PCB design are the actual layout of the components themselves and the traces or tracks connecting the components together. The first thing to consider, which is often overseen, is the necking of component tracks or traces when they attach to a small surface mount pad. This commonly occurs with power or high current tracks, where on the rest of the PCB the tracks are very wide and the tracks are then wider than the actual component termination. What happens here in a number of cases is once the track attaches to the component, it makes the component land wider than it really should be because the track is wider, but with the solder resist aperture, that then still makes the component wider, and you should have seen an example of how that can lead to bridging on components on your screens. The next thing to consider is the thermal balance from one side of a component to the other. This particularly comes into account on chip resistors and capacitors, where if on one side of the component you've connected directly to a ground plane and on the other side of the component you've connected via a small signal track to some other part of the circuit, you find that the component may in some cases tombstone because the two terminations on the component heat up at different rates, and therefore the solder will actually pull the component either off the pad altogether, in which case it will tombstone, or it may just shift the component off the center of its pad, which although is acceptable can lead to problems later on. Another thing to also consider again with components is via pads. It's often the case on double-sided and multi-layer PCBs that you need to make a via interconnect from a surface mount component to another layer in the PCB. A common mistake when placing the vias is to attach the via pad directly to the land pad of the component without leaving a small trace in between to provide a thermal break. If this happens, we can again get the same occurrences of tombstoning, or even worse, if the via hole itself is too close to the pad, we can get solder thieving, where the solder paste that should be forming the termination of the component on the PCB actually flows down into the via hole and then leaves us with a dry joint. Finally, just to finish off on this topic, a common occurrence is to actually place via holes in the pad of a component. Now, in a normal component termination pad, this should never be allowed under any circumstances, but quite commonly now, larger components such as QFNs and QFPs tend to have a central heatsink ground pad in the middle of the component underneath the device. And these are generally recommended to have via holes connecting them directly to the ground planes inside a multi-layer PCB. While this obviously is a design requirement, consideration should be taken of the fact that these holes in the pad will thieve solder that is required to ground the device. So we recommend that either the via holes in those pads are kept to an absolute minimum, and also the size is kept to a minimum, and we would recommend 0.3 millimeters, which is the smallest size that can be mechanically drilled. If for design requirements you require the via holes to be larger in size, then we would have to look at performing an extra operation in the manufacturer of the PCB, which is to epoxy fill the via holes and then plate afterwards. So the pad surface will appear as if there are no drill hits in there at all, and therefore won't be able to thieve any solder. Feel free to contact us and we can discuss compromise on what gaps we are able to achieve on your particular product, and hopefully save you some money in the process.
Thank you, Mike, for that. I hope you all found that interesting and helpful. If you want some more design tips from Mike, don't forget to subscribe to Cogent Technology TV. We'll see you soon.